Okay, so let's read the rest of this story on the Arctic report card for from NOAA. We stopped at the end of the summary before and looked at various headlines already. We'll look into more details of individual indicator variables. So, as we said before, air temperatures at the annual scale are described in terms of the water year, that is October 2023 to September 2024, representing the year 2024 in the graphics. 3-month seasons are therefore referenced to as follows. Autumn goes from October to December of 23, winter January to March of 24, spring is April to June, summer July to September 2024. These seasons span the annual cycles of vital sign variables consistently described in the Arctic report card. So it's not key indicators, they call them vital sign variables, which is a better way to say it, since so much of the ecosystem also depends on how the Arctic is doing, Arctic sea ice is doing, polar bears, the permafrost, the tundra, and all the species that depend on them. So I'm going to skip a lot of the details and just grab headlines for each vital sign. Let's use the right terminology. For temperature, Arctic annual surface, let's bring up Arctic annual surface air temperatures for October 2023 to September 2024 ranked second warmest since 1990. This consistent with the global temperatures. And you have to be careful, because when we are talking about global temperatures exceeding 1.5 and so on, they are usually only averaging over 60 south, 60 north, whereas this one is focusing more on the Arctic, but it's doing the water year, whatever they call it, right? So autumn 2023 and summer 2024 were especially warm across the Arctic, with temperatures ranking second and third warmest respectively, and early August 2024 heat wave produced record daily temperature maxima in several northern Alaska and Canada communities. This is critical. Now heat waves are hitting the Arctic and the Antarctic more often than we would like. Summer, and you probably read a lot about how Antarctica has become vegetated in many places. It's blooming with these little tundra-like vegetation that how warm does it have to get for Antarctica to start seeing vegetation again, since the glaciation started 34 million years ago, right? The headlines for precipitation: summer 2024 precipitation averaged across the Pan-Arctic was at a record high. During 1950 through 2024, annual precipitation has increased, and the increase is most pronounced in winter. During October to December 2023, there was below average precipitation over the East Greenland and Barents Sea, and above average precipitation extending. So there are different sectors seeing different amounts, as we saw before, and anomalies also above or below average, wet or dry. And these are just some of the data. So water year again, October to September, October 23, September 24. Two products. ERA 5 is the reanalysis, GPCC is observation based estimates. So these are percentage of 1990 to 2020 average. So you can see some excess, more than 100% of the baseline, but it's relatively flat there. So we have gone from 1950 to 2024 upward. The water year entire annual precipitation. Autumn again relatively flat, seems like going up here, but then it has remained relatively flat with just some interannual to decadal variability in both products. Winter months, again some trend maybe, but relatively flat since about 1990 or so. People squeeze these to say whether there was a regime shift and so on, so forth. So spring similar, summer similar. So only this one shows maybe they're all similar. Let's not make much out of it, but we already read about how the trends are interpreted. Snow accumulation, you can see here, this is the May snow equivalent. Ta-da-ta-da! Right? Snow content equivalent anomaly, snow cover extent anomaly. Sorry, I'm trying to make things up. That's bad, man. So, snow cover extent anomaly. This is North American Arctic and Eurasian Arctic. Some differences, but basically both are tending downward. So, you have to always reconcile with what the precipitation is doing and what the snow cover extent is doing to see how precipitation character is changing, right? So, snow accumulation during 2023-24 winter was above the average across both Eurasian and North American. So, those points are here. Early snow onset and delayed spring melt resulted in a longer than average snow season over much of the Eurasian Arctic. So, warm year, but snowfall more. Not contradictory, because warm atmosphere holds more moisture, which can increase snowfall, right? It may lead to other impacts on sea ice that we will look at in a minute, another vital sign. Over North America, and then so just compared to historical conditions, Arctic snow melt over the past 15 years has commonly occurred 1 to 2 weeks earlier throughout May and June over both Eurasia and America. So, this is the May snow cover extent and June snow cover extent. This has a much stronger trend than what we see here. Okay, so obviously there is seasonal dependence as you come out of the winter and spring into summer, and regional differences, Eurasia versus North America and so on. The Greenland ice cover sheet, obviously there is no good news there. We have seen this before. So, this is mass in gigatons relative to September 01, 2023. So, there is some data gap, but you can see that this just continues both from IceSat 2 and GRACE follow-on mission. Two satellites. GRACE is more a gravity measurement, two satellites flying together that estimate mass. IceSat is doing different things in terms of what it is measuring. I won't go into the details here. So, flow rates of ice into the ocean in 2024 were substantially above the 1991 to 2020 average, despite moderate slowing since 2022. So, you know, this is basically, there are many regions where the mass loss is accelerating. Calving we talk a lot about in Antarctica, because a lot of the glaciers flow onto the Southern Ocean and all kinds of interesting complicated interactions happen. You don't hear that much about Greenland, but that's going through the same thing. When you hear about Greenland glaciers, you're mostly hearing about moulins, where top of the glacier is melting, melt pond forms, albedo drops, more heat goes in, and then the water begins to drill into the glacier, and then you have massive waterfalls that can reach the bottom and lubricate the bottom and accelerate the sliding of the glaciers and so on. This is the oops, did I go back? Let's see. Headlines: sea ice extent. So you can see in millions of square kilometers, a slight downward trend in March since 1979. September total extent has a larger drop, which is important because September extent is critical for growing it back during the fall winter months. So if you are losing a lot of it, then the winter sea ice extent is going to be smaller. And you can also see that the September multi-year ice extent is dropping, which means you are finding refreezing or ice that is newer, right? So it's 1 year, 2 year old ice as opposed to multi-year ice, which is important because that's inertia. I want as much multi-year ice as possible. So again, no good news on sea ice extent, which we have looked at elsewhere already in a different context. Again, as I said, this is about the report card for 2024, and there is a lot of specific 2024 data presented in the report, but I'm just still sticking to the trends because I find individual years to be somewhat I don't like looking at individual years because internal variability can be high, and 2023-24 were really warm because of the overlap of the strong El Nino onto global warming, plus few other things like maybe reduced aerosols, the Hunga Tonga volcano that went off in 2022, and so on and so forth. So we are yet to explain why it got so warm and so on. So now looking at sea surface temperatures as opposed to air temperatures, they were 2 to 4 degrees C warmer than the 1991-2020 August mean values in most of Antarctic Ocean marginal seas. So this is August 2024 relative to the baseline. Can see lots of warm anomalies here, up to 5 degrees, especially as you get close to the coasts. And there are, of course, regions where there was some cooling seen as well. So this is the problem of looking at individual years. And nonetheless, they are important. There is sea ice here, so we are looking at only sea surface temperatures where you have open seas. But the these data still are important because you want to see if a warm year can set off extensive ice melt that will not recover, or buildup of sea ice that may persist into the following year. August is a good month to be cool because September sea ice loss is what we focus on. So if this can help keep the September sea ice from melting, then obviously that could be good news as well. Okay, so this is the 1982 to 2024 SST linear trend. This shows what I was saying before, that individual years can be high internal variability. So cool anomalies here of 5 degrees, but actually in the long run either we don't have significant trend or it's all warming. So unlike the Antarctic, where you get mixed trends because of this complex interaction between the Southern Ocean and the atmosphere and the specific parts of Antarctica, you're basically seeing warming everywhere, especially even into the open oceans. We don't see the warming, the whole that we typically see in the global map. It's a bit further to the south, I suspect, but this is only for August, so you have to be careful as well. Okay. I think this is this per year, not just August. Okay, so again, individual years give some message, but trend continues to be the same in terms of sea ice loss, precipitation changes, and SST warming. Right. Headlines for ocean primary productivity. I won't go into the details because these tend to be tricky in terms of just the extent and the signal. So I'll just show you the trends in annual primary productivity. So you expect the warming to be consistent with primary production because that generally favors the circulation changes, nutrient supply, light availability, just exposed waters where biology can happen. So there is always somebody in nature that benefits. So if sea ice is lost, then phytoplankton will come in and start to grow. So there is positive trends here in grams of carbon captured per meter cube per year per decade. So it's kind of a complicated, because you are taking productivity during a year and seeing how they are changing decade to decade. Okay, so lower than average values of annual ocean primary productivity were dominant across much of the Arctic during 2024. Higher than average values were observed in eastern Hudson Bay, Canadian archipelago, and Canada is here, and Hudson Bay has to be somewhere here. Eastern Hudson Bay, Canadian archipelago, and sub-areas of Kara and Laptev seas. So you have to go and geolocate yourself on this. But these things matter because you can also have feedbacks, whether the phytoplankton will begin to have positive feedbacks in terms of the heat balance in the mixed layer, or it will actually cool the ocean, So there is warming trends, and there are positive primary productivity trends. So you have to figure out whether the primary production, increasing primary production, is having a positive feedback on the warming or not. Okay. This is for circumpolar mean maximum tundra greenness value. This was the second highest in the high resolution 25-year MODIS satellite record. That was 2024 was the highest, continuing second highest, continuing a sequence of record or near record high values since 2020. Is that good news or bad news? Obviously, you have to figure out whether it's all happening because of permafrost thaw or whether it's also having a positive feedback on that and so on. Tundra greenness reached a record high value over the North American sector, while the value in the Eurasian Arctic was sixth highest in MODIS record. So there are region-specific responses. As you can see, the colors are much greener here. This is the maximum NDVI trend for over 2000 to 2024. So that's unitless per decade. Greenness is a unitless metric. Okay, so you can see lots of increases in greenness, except for little patch here, which is in the negative range. The greening of the Arctic, first reported in the late 1990s as an increase in productivity and abundance of tundra vegetation due to rapid warming and sea ice decline, is an ongoing phenomenon evident in all available long-term satellite records. Again, this is a land response to Arctic warming and sea ice decline, because sea ice decline again increases ocean albedo or decreases ocean albedo and can put more energy into the ocean and accelerate the sea ice loss and overall affect the Arctic climate. There are humidities, cloud feedbacks, and of course ice albedo feedbacks happening there. Okay, so the ecosystem headlines: Arctic migratory tundra caribou populations have declined by 65% overall over the last 2 to 3 decades. More recently, the relatively smaller coastal herds in the western Arctic are showing signs of recovery, while the larger inland herds are either stable or continuing to decline. I always say the old line that nature makes the rules and biology finds the loopholes. Depending on how fast things are changing, biology in general looks for either refugia or to fill in the niches that are favorable and move away from niches that are unfavorable, or they just decline. Warmer summer and fall temperatures, changes in winter snowfall, and an increasing human footprint collectively stress Arctic caribou, altering their distribution, movement, survival, and productivity. So they are migratory animals, so they can move away from unfavorable conditions. The extent of recent herd declines and onsets of recoveries varies regionally, consistent with regional climate trends. Arctic regions of greatest projected summer warming are so I should have made a full stop there. The extent of recent herd declines and onsets of recoveries varies regionally, consistent with regional climate trends, right? We already saw that. Arctic regions of greatest projected summer warming are projected to see the largest continued population declines. Summer warming, permafrost thawing, loss of vegetation, you have to see when the greening happens, how it affects the caribou and so on. But summer warming is generally bad news for the caribou, but do they move elsewhere or do they actually decline in total number? That we have to look up. Sharing knowledge is essential, as those charged with managing caribou endeavor to more fully understand climate impacts on herd health and implement strategies that encourage herd growth while accommodating the cultural, nutritional, and spiritual relationships northern people have with caribou. So with warming, microbes can explode and disease pressure can grow as well. And obviously the warmer the temperatures, the less the climate hammering of the pathogens. More pathogens survive for longer in a year, the disease pressure obviously increases, which can add to other factors in the herd decline. For wildfire emissions, the Arctic tundra region has shifted to a carbon dioxide source and is a consistent methane source as well. So you're looking here at trends from 2001 to 2024 in terms of burned area in millions of hectares per year and carbon emissions in teragrams per year. So you can see there is a jump here. Is that a trend, or is that a regime shift of some kind, or was it just related to the unusually warm 23-24? So you have to see that there is large interannual variability as well. Okay, so this is terrestrial ecosystem CO2 balance, and you can see there are still some sinks, as you can see in the blue colors. This is terrestrial ecosystem CO2 fluxes with direct fire emissions in red shading for the northern permafrost region. So that's 2002 to 2020 average, showing areas that are CO2 sources in pink and red and CO2 sinks in blue. Okay, so overall averaged, if Arctic is becoming a source of CO2 instead of a sink, and also releasing methane, then again you have to see whether that's being taken away or it's getting trapped and having any amplifying effects, adding to the polar amplification that's already so strong. Okay, so warming and wildfires go together, and you don't imagine warm wildfires, but Canada has now become quite notorious for its wildfires. In fact, in 2023 emissions from Canadian wildfires were quite significant and may have contributed to the warming as well. Ice seal populations in the Pacific Arctic, so there are several types. Ringed, bearded, spotted and ribbon seals remain healthy, so that's good news. Monitoring the subsistence harvest since the 1960s show no sustained change in body condition, a stable or younger age of maturity, high pregnancy rates and pup survival past weaning. Weaning is when the baby goes off on its own from the mother. As predicted, with warmer water, fewer ringed seals are eating Arctic cod and more are eating saffron cod. However, no concurrent changes in health are evident. So they shift their diet based on what's available. They're adaptable, but there is a bit of a good news here in terms of their population being stable and the production cycles, breeding, etc. going on well as well. Inuit hunters, this is the next headline. Inuit hunters are the original researchers of their homelands. Observation, monitoring and research skills are all integral parts of being a hunter or harvester. In general, the assumption is that they have learned to live in harmony with their environment over time. And we have created hazardous conditions for their lives and livelihoods. The Itak Heritage and Research Center in Kanjiktugapik, Clyde River, Nunavut, Canada runs the Angunasukit program. I am massacring these, but sorry. A full-time land-based program that we are talking about here that teaches all aspects of hunting and harvesting to the next generation so that the lifestyle can be maintained. Supporting the participation and leadership of the indigenous peoples in broader Arctic research must include the sustained support of indigenous ways of life on the land and generating knowledge. Okay, this is like live instruments that are living there and collecting data for you, crowdsourcing, etc. So here are some nice figures of the caribou and the different kinds of seals, ringed, bearded, spotted and ribbon, which you can clearly see here. Okay, this is the Inuit kids getting trained on various things by the elders so that their livelihoods, lifestyles can continue. Okay, sorry for being brief, but obviously it's a nice long report that you can read if you are interested in more details. I just wanted to give a brief introduction as usual, and we did it over 2 podcasts, so it's not that brief, but still the report is quite comprehensive that you can follow up on. Okay, see you in the next topic.